So for Mr. Mitchell's topic 8 test, I have removed questions 11, 13, 20, and 16 and 9 from the review, and I've replaced them with 5 questions from the unit quizzes. And I'm going to go through each of those 5 questions. I'm going to change the numbers on most of them, just so you have an idea of how to set up the problem, how to solve it. And then on the day of the test, of course, it'll be for you to plug everything in correctly. So our first question that I've added says, what is the angle of elevation? So I'm going to highlight that to the nearest tenth of a degree. I know where I'm most likely going to make a mistake here personally is in the rounding. To the top of a 35-foot tall building. They didn't say tall, I'm adding that from 75 feet away. So I'm going to draw my building. I'm going to mark that it's 35 feet tall. And then I'm going to make a line that shows me it is, for where I'm looking, is 75 feet away. Next, it says angle of elevation. So that would be this right here. If I was standing here, I'd have to look up like that. And that means if my gaze from the ground level is here and I rotate my eyes upwards, I want to know what angle or how much would I have to move my eyes, what would be that measure. And we're going to use theta to represent that. So to solve this, we're going to have to figure out which trig function do we want. Well, the first thing I say to do every time is looking at your reference angle, right? This is the opposite side. So I'm going to go ahead and mark that as opposite of theta. And then I'm going to do the next easiest thing to identify, which is my hypotenuse. That's just for the right angle. Where the ground meets the building is going to be my right angle. It's going to be my hypotenuse. And I'm not going to put a reference angle here because that's just a part of the triangle. It has nothing to do with that actual angle. And if I know the opposite and the hypotenuse, all that's left is my adjacent, and I'm not going to make any mistakes in setting that up. So this is adjacent. And then I have to determine what pieces of information do I have and how do I go about setting them up with a known trig function. On the bottom of our screen, we can see we have sine, cosine, and theta. And here I can see I have opposite and adjacent, and that is tangent for us. So here I'm going to say the tangent of theta is equal to the opposite length over the adjacent length. It's going to be the tangent of theta is equal to the opposite over the adjacent. Now we can plug that into a calculator to see what we get. 35 divided by 75 is 0.46 repeating. Don't change anything in your calculator. Don't round this. Leave exactly that. And then you're going to hit second tangent to get the angle. And that has a measure of 25.01. Double check what it wants me to round to. Tenth of a degree. So then I look from here to here. This is a 1, so this stays the same. And we have an answer of 25 degrees. All right, for the second one, change the numbers that were given. And it wants to know what is UT. That is this line segment right here. So we're just going to call that X. And since we have a right triangle and we know 2 of the sides, we can use the Pythagorean theorem to solve for that missing side. The only thing I have to do to make sure it lands in the right place is that I have this right angle points at the hypotenuse every time. And the hypotenuse is always equal to C. So I'm going to end up with 5 squared. And then I have A squared and B squared. Now, if you think about it, and I'm just going to do a little aside here, and maybe this purple. Is there a difference in these answers? No, they're both 7. So it doesn't matter which order I add them up. What I like to do is start with my unknown. So it's going to be x squared plus 3 squared, where this would just be my side A and this would just be my side B. Obviously we can't do anything with the x squared, but this is going to give me 9 and 25. Subtract 9 from both sides. This gives me x squared equals 16. And then if I take the square root of both sides, I get x equals 4. So my answer for this would be 4 for the length of UT. All right, number 3 on the replacement question, it says find the value of x to the nearest tenth. So let me highlight that nearest tenth again, just so I have something to catch my eye when I think I'm done. Make sure I've done this right. So I have to ask myself, what do I know? What don't I know? Do I have opposite knowns? Do I have opposite unknowns? If I know that if I know an angle and its opposite side, I'm going to feel pretty good about being able to use the law of sines as long as I have another angle and its opposite side. And in that second grouping, there's an unknown. And what I mean there is I'm going to just do this every time. I have the sine of something over something is equal to the sine of something over something else. And what I always do is I ask myself, do I have an angle and its opposite side that are known in my given? And here I have this angle 40 degrees and its opposite side. So those are going to go right into my left-hand side. Degrees always go with my trigonometric function. And my side length always goes in the denominator. My second question in determining whether or not I can use the law of sines is, do I have a second known and its opposite side or its opposite piece being unknown? And here I do. This is going to be sine 92 over x. And now I can use the law of sines to solve for x. If I didn't have this, maybe I had instead x was already known and it wanted me to find the side length, the third side length, then I would need to use the law of cosines for that. And I'm sure, if I remember correctly, that's the next one we're going to cover here. But for this one, let's start by cross multiplying. X times sine 40 and 14 times sine 92. Keep my equal sign, even though I've completely obliterated it. And now I have to isolate my x. Never forget that the sine 40 here is just a number. And if I have x times the number, to undo that, I divide by the number. So I'm going to divide both sides by sine 40. Divide by sine 40. Since these are both just numbers and they're the same, they will cancel out and I'll be left with x equals 14 sine 92 over sine 40. And I can put that in the calculator. Now what I'm going to do is write out the steps if you're using the TI-30XA. Because again, that is the only calculator that we'll have during the EOC. I always start in the numerator and I go right to left. So I turn on my calculator and then I punch in 92. Then I hit the sine button. Then I do times 14 and then I hit equals. Anything I box in is an actual button on your calculator. If it's just numbers, that's what you should punch in at that time. This takes care of my numerator. I found the value for sine 92, and then I multiplied it by 14, and I asked, what does that equal? And now I can move into my second part, which is divide by. That's what that bar means. So now I'm going to hit divided by. And again, I'm going to work from the inside out. I'm going to punch in 40, hit the sine key, and then the equals key, and that'll give me my answer. I'm going to do it really quick on mine, so that you can check to see if you did it on yours. And I got, let me change the color. This doesn't seem dark enough to me. This is equal to 21.76. It does say nearest tenth, so that means I look here to here. And my final answer will be 21.8. All right, on your test. This one's going to be multiple choice, but since I have to change the side links, I also went ahead and erased the multiple choice options, because if you see those and you see obviously my answer doesn't match one of them, you might not feel too confident, and I don't want to set anyone up to kind of think, oh no, his answer is not on my options on the test. So if you look here on the bottom left of your screen, I have the law of cosines up, so I'm going to use that. I'm going to go ahead and recopy it up here so we can talk about what it is, why I use this version, and how we settle it. So since you guys started in pre-algebra, you've always been looking basically for x. You're always solving for x. So I like to put x on the outside because one of these is going to be known. And the other unknown. Now, we obviously could not use the law of sines here because I don't know any of the angles yet, so I can't have the sine of a known angle over the known side is equal to the unknown. So I am forced to use the law of cosines here. So what I have to determine is which of these x's can I replace with something that's given to me, and which of these x's is going to remain my unknown. Well, since I'm looking for x in my as an angle, I know angles always go here, so that's going to remain my x. And to identify what is replaced here, I just go to the side opposite of that angle, and this is going to be 4. So let's clean this up a little bit and then move back into actually doing the work on this question. Again, we have y squared plus z squared, and we know we can add in any order, so it doesn't matter which one we pick for y and z. This is why I like to break it down this way. It just makes it easier to see what we're doing. Again, that's my unknown, and that's its opposite side. The side is always on the left, and the angle is always on the right. I can choose either 3 or 5. It does not matter for y and z. So since I have y on the left and z on the right, I'm going to put 3 squared since it's on the left, and then 5 squared for z, or 5 for z. It's going to be minus 2 times 3 times 5. And we're going to make one minor change here. Since I'm still looking for an angle, I'm going to make this my inverse or arc cosine, since that tells me what the angle measure is at the end of a problem. Let's start doing, oh, what I forgot. 4 squared is 16. This is 9. This is 25. 2 times 3 is 6, times 5 is 30. And I still have inverse cosine of x. Now, a lot of people like to just do 9 plus 25 minus 30 and plug all that in. Remember, if we're following the order of operations, this is multiplication here, right? This is negative 30 times whatever number or whatever our angle measure is. So we can't do that until we can break that 30 away by doing the opposite of multiplication, which is division. So, but I can combine these like terms since the sign between them is addition and there's no multiplication, no exponent attached to them. This is going to give me 34. And now I have 16 is equal to 34 minus 30 inverse cosine of x. Again, I still cannot do 34 minus 30 because I have this multiplication going on. But what I can do, since there is a minus sign between these two terms, is subtract 34 from both sides. Is this going to give me 18? Oh, sorry, negative 18. This is 16 minus 34. Yep. This becomes negative 18 is equal to negative 30 times inverse cosine of x. And now I finally chipped away, and I'm so close to getting to my cosine being alone that I can now divide both sides by negative 30. And this is going to be 18 over 30. Notice I have a negative and a negative here. If I take two negative numbers and divide them, they always become positive. And this is inverse cosine of x. So on my calculator, this one's a little nicer to us than the last one. I'm going to do 18 divided by 30. That gives me 0.6, and now I'm just going to hit second, cosine, and then equals. And I get, oh, no one's the nearest tenth, so we're not going to use an equal sign. We're going to say it is approximately 53.13. And of course, when I round it, it stays at that, and I just have 53.1 degrees for X. All right, so now we have the angle of elevation from a viewer to the center of a fireworks display is 55.5 degrees. If the viewer is 100 yards away from where the fireworks are launched, at what height is the center of the display round to the nearest whole yard? So double check that they did give us our measurement in yards and we don't have to do any conversion, and we're good. Let's see. They're 100 yards away, so that does belong down there. And it's basically asking how high does the firework travel from the point on the ground where it launches up to the center of its explosion. So what I want to ask myself is, what kind of relationships do I have here from the angle in which the viewer is standing? If I cut through the two rays and go to the opposite side, I have the opposite. So this is the opposite. And then obviously, when the firework leaves the ground and travels straight up, it's going to be perpendicular to the ground, making this side the hypotenuse. Gotta turn off my arrow tool. Give me 1 second. And then whatever's left over is going to be my adjacent. All right. So if I look at this, I want to know what the opposite side is, and I know the adjacent. I also know the angle. So again, I have an opposite adjacent setup, and that's going to be the tangent. This time I don't need a theta here because that's not what I'm solving for. I was given the angle of elevation here. I'm not going to put the degrees in there. I've been doing that. Not going to start now. And then tangent is just opposite over adjacent. And I can do some simple algebra now to solve for x. Anytime I have something in the denominator, the first thing I do is multiply by what's in the denominator, distribute it in, and I'm going to have 100 times, I'm not going to put that symbol. We know when we butt them up together, it means times the tangent of 55. And here, when I multiply this in, I'll have 100x over 100. These will cancel, and I'll be left with x. So now all I have to do is plug that into my calculator, and we're good to go. Now make sure you do 55 tangent times 100, and you get x is approximately 142.81. And then go back and double check. I forgot to highlight it this time, so it's not standing out. Where am I supposed to round to? The nearest whole yard. See, and this is what I mean when I say I always make up whatever random position to round to, and then I end up getting it wrong, so I have to go back and read the question. So here is whole yard, so I'm going to go from the 2 to the 8, and that tells me to increase this by 1. So it's going to be 143 yards, and it looks like, nope, you just put 143. All right, and our last question that I added says, what is the angle of elevation? So I know I'm going to have to find theta here. From the ground to the top of a 20-foot tree from 15 feet away. Let's draw this. Let's keep it simple. Here's my tree. We know it's 20 feet tall. And we know we are 15 feet away. I'm not going to be able to draw that straight line. So let's say we're about right here. And that's 15 feet. How much would I have to look up? Oh, I didn't turn my straight line tool on. Well, how much would I have to look up, or how much would my horizontal gaze, or my gaze that's parallel to the ground, have to rotate upwards to meet the top of the tree. So we're looking for this right here. And what I want to do, same thing as always, even though most of you are already telling me, or in your mind, you already know exactly what it is. If I start at the angle that I'm looking at and I go straight across, this is going to be my opposite. And then I know where my tree meets my ground. It's going to be roughly 90 degrees. Well, in this perfect scenario, since I drew it to be that, it is 90 degrees. And this is my hypotenuse. Meaning whatever is left is my adjacent. And once again, we are using tangent. And we know that we want to find the angle. So the tangent of theta is equal to the opposite over the adjacent. Now look at this. We have an improper fraction for the first time in any of these problems in this video. It'll still work though. So we're going to follow the same steps as well. It's going to be 20 divided by 15. That's giving me 1 1/3. And now I'm going to hit second tangent. And it tells me that I have to look up at approximately 53.13010. This is nearest tenth. So if I start here and look here, my final answer is 53.1 degrees. Okay. So again, I did trim out all this like that. Select all that apply, drag and drop, and the drag down menus to pick the law of sines and the ratios. I try and avoid those, especially at the end of the year when we need to shift our focus from test corrections and stuff into the EOC mode. So that's where we're at right now. Hopefully this is helpful. And if you guys need anything, just let me know.